Alright, AP. No joke, I shot this video and it decided to corrupt when I was saving, and now I have to do it all over. So that's why you see these papers organized in a way to hide the solution. So we're reviewing section 7.6 and 7.7 from AP Classroom. These are equivalent to 7.3 in the resources we're using on that ongoing Google Doc. All 4 forms for 7.3 have already been posted. Okay, so again, 7.3 reviews AP section 7.6 to 7.7. Okay, so in this one, we're still continuing methods for solving differential equations. In particular, the skill here is separation of variables. So number 1 here says use separation of variables to find the general solution dy over dx plus 4x y squared is equal to 0. Now what you're going to want to do is you're going to want to get the x's, everything with the x's on one side and everything with the y's on the other side of the equation. Okay, so what I'm going to do here is, okay, so this is 7.3 Form A number 1. Okay, and I had dy dx plus 4x y squared is equal to 0. What I'm going to do is, first, I think this term here that has the x's and the y's together, I'm going to move him over to the right side. So I'm going to subtract 4x y squared to both sides. And when I do that, I get dy dx is equal to negative 4x y squared. Again, all I did was I subtracted this term over to the right side. Then what I'm going to do here is I can multiply both sides by dx. Right, the dx will cancel there. And what that's going to do is I'm going to get dy is equal to negative 4x y squared dx. Okay, and lastly, I'm going to divide both sides by y squared. Okay, the y squareds will cancel there. And so I'm going to have another way to rewrite that is having 1 over y squared dy is equal to negative 4x dx. Okay, one last thing I'm going to do is, I don't like this right when I need to integrate or derive, so I'm going to go ahead and use the negative exponent rule and write that as y to the negative 2 dy. That's equal to negative 4x dx. Okay, now I can integrate both sides. So right here, if I'm going to integrate this, I'm going to add 1 to the exponent and divide by that new exponent. So if I add 1 here, I get negative 1, so I'm going to divide by negative 1. So if I divide by negative 1, I'm just going to get negative y to the negative 1 is equal to, here, add 1 to the exponent, I get 2, so divide by 2, negative 2x squared plus c. Okay. Now y to the negative 1, let me use the negative exponent rule there, and I'll get negative 1 over y. That's equal to negative 2x squared plus c. Okay, now I'm going to multiply both sides by y. Okay, what that's going to do is these y's here will cancel, so I'll be left with just negative 1. Now on the right side, I'm not going to multiply that y in. It's not the point. I just need to get the y away from the denominator. Okay, now I can divide both sides by this whole thing in the parentheses. So those will cancel. And so then my answer will be y is equal to, I got negative over negative, that'll turn positive, so 2x squared plus c. Okay, that'll be my answer. That'll be the general solution. Alright, for number 2, have this here, not to confuse you guys. It says find the particular solution for the differential equation. Then I have dy over dx is equal to 2xy, and y is equal to 3 when x is equal to 0. Y is equal to 3 when x is equal to 0 is just another way of writing this is a point on that equation, 0, 3. Okay? So to find the particular solution, that's why they gave us that point. So we're going to be doing the same thing, just using this point. So dy over dx is equal to 2xy. So let's go ahead and work with that first then. So number 2 here, I have dy over dx is equal to 2xy, and again I have a point 0, 3 that I'm going to be using. Okay. So similarly, I'm going to want to get my x's and y's on one side together. One thing I can do first here is multiply both sides by dx, right? And if I do that, I'm going to get dy is equal to 2xy dx, like that. And then finally, I'm going to divide both sides by y. So I should have 1 over y dy is equal to 2x dx. This 1 over y, I can use the negative exponent rule to write that as y to the negative 1. dy is equal to 2x dx. And now I can integrate. Okay, if I add 1, let's see, yeah, that's right. If I add 1 to the exponent here, negative 1, that's not right. No, sorry, that's actually completely my mistake. Maybe I don't need the y to the negative 1, like I said I would. If I have that 1 over y and I integrate 1 over y, right? Do you guys remember? It's my mistake here. ln of u, right? If you take the derivative, that'll be 1 over u. And so then if you take the integral of 1 over u, you get ln of u. So this will be the ln of y, absolute value of y, okay, is equal to, again, the integral of 1 over y would be ln of y, okay, because of this property here. And the integral here, if I add 1 to the exponent, I'll get x squared, divide by that 2. So I should have just x squared plus c. Okay? Just like that. Now, I could go ahead and plug in the 0, 3 here to solve for c here, but that probably won't be necessary. One property, if you guys recall, is when working with the natural logs and solving natural log equation, is you might want to raise both sides to the e. What that's going to do is it'll cancel out with that ln, that natural log, and you'll get y is equal to e to the, and I got x squared plus c. Okay. Another way to write this here, right, is using the product rule of exponents, just like that. So then another way to rewrite this would be c times e to the x squared, and so y would be equal to c times e to the x squared, whoops, right there. And now I can use that point 0, 3 here to solve for c. And so then when I do that, if I plug in the 0, 3, I'm going to get that y is 3, c times e to the 0 squared. That'll just be e to the 0, which is 1. So then I get that c is equal to 3. And so then my solution here will be y is equal to 3e to the x squared. Just like that. Okay. no, sorry, this is the solution here. It'll be y is equal to e to the x squared plus 3. This one right here. Okay. Alright, next one is number 3. So it says find an equation of the graph that passes through the point. So we have 3, 2 and has the slope. We have dy dx is equal to 2x 3y, and we must write our answer in standard form. So ax squared plus by squared is equal to c. So we're working with this differential right here. So as you can see, it says it has the slope dy dx is equal to 2x over 3y. It's the correct form, right? It's form A? Yeah, it is. Okay. So then, okay, we also have this point. We said 3, 2. Okay. I think the fastest step here would be to just cross multiply. And when you cross multiply, again, dy with 3y, 2x with dx, you're going to get 3y dy is equal to 2x dx. Right, a much more express way to do this. So then now I can set up the indefinite integrals here and add 1 to the exponent. I get 2, divide by 2, this would be 3 over 2 y squared is equal to, right here, add 1 to the exponent, divide by that new exponent, so 2. The 2's will cancel, so x squared plus c. Okay, I'm going to subtract the x squared over to the left side, and I'm also going to put it first, so I have this right here. And as you guys can see, that's very close to standard form, right? Standard form is ax squared plus by squared, sorry, is equal to c. Okay, now by having this form here, I can actually go ahead and plug in my points, right? That's my x and that's my y. So if I plug those in, I'm going to get, let me see, I have negative x squared, so that would be negative 3 squared plus 3 over 2, 2 squared is equal to c. Okay, so 3 squared, that's negative 9. Okay, plus 2 squared, that's 4 times 3. I'm going to get, that's going to be, I'm drawing a blank here, 6. It's equal to c. And so c will be equal to negative 3. And so then I can now go back and plug it into this form right here. I'll get negative x squared plus 3 over 2 y squared is equal to negative 3. Okay, and another way to rewrite this will be, right, I don't want that fraction, so I can multiply everything by 2. And I'm going to go ahead and multiply actually by negative 2. So I can get rid of that negative in the front there. And I'll get positive 2x squared. And it's okay to multiply by positive or negative, just make sure you have the right signs for everything. Okay? So then this guy right here will be negative 2 and the 2's will cancel, but negative 3 y squared. And negative 2 times negative 3, that'll be positive 6. Okay, and there's your standard form solution. Now for form C, I strongly encourage that you, now that you've seen the 3 examples here for form A, that you pause the video, okay, and attempt to do each of these before I go ahead and complete them. Okay, so this first one says use the separation of variables to find the general solution. It's dy dx minus 6x y squared is equal to 0. Okay, so again, please pause the video, attempt to do this first. Okay, study how we did number 1 in form A and see if you're able to do this one. Okay, so then here I'm going to add the 6x y squared to both sides. Okay, so I get positive 6y squared on the right side. Then I multiply both sides by dx. Oops. So if I multiply both sides by dx, I'm going to get 6xy squared dx. Okay, sorry, I made a mistake there. Then I'm going to divide both sides by y squared. Okay, those y squareds will cancel there. And so then right here on the left side, another way to write this right will be y to the negative 2 dy. That's equal to 6x dx. Like that. Okay, now I can go ahead and integrate. And if I do that, I can add 1 here, right? I'll get negative 1, divide by negative 1. So I get negative y to the negative 1 is equal to, here, add 1, I get 2, divide by 2, I get 3 x squared plus c. I think this will be similar from here, right? I can rewrite this here to be negative 1 over y is equal to 3x squared plus c. I can multiply both sides by y. What that's going to do is the y's will cancel on the left side, so I get left with negative 1 is equal to 3x squared plus c times y. Divide both sides by 3x squared plus c. Those will cancel, and I'll have y is equal to negative 1 over 3x squared plus c. This would be the general solution. Okay. Now for number 2, here's number 2. It says find the particular solution for the differential equation, and we have y dy over dx minus 2 e to the x is equal to 0, and y is equal to 3 and x is equal to 0. So this is just another way of writing this point 0, 3 when y is equal to 3, x is equal to 0. So it's just 0, 3. Okay, and I'm gonna have to find that particular solution then. So go ahead and pause the video again and try to see if you can do this on your own and then compare the solution. So we're working with y dy dx minus 2 e to the x is equal to 0. Okay, and we have this point here, 0, 3. So first thing I'll do is I am going to add the 2e to the x over to the right side. So I have this so far. Then I can multiply both sides by dx to isolate the y's on the left side, just like that. Okay, so again, I multiply both sides by dx, they cancel that on the left side, so I have y dy is equal to 2e to the x dx. Now I can integrate. Here, right, add 1 to the exponent, divide by it, I get 1/2 y squared. On the left side, right, 2 is just a coefficient there. The integral of e to the x is e to the x, so I'll get 2e to the x plus c. Okay. Yeah, that looks about right. So the next thing is, actually before, well, I guess I could go ahead and subtract the 2e to the x from both sides to go ahead. I guess that won't be entirely necessary. So if I have 0, 3 here, okay, I can go ahead and already plug this in. So my y value is 3, right? So okay, this is my x and this is my y. So if I plug in my y value, I get 1/2 3 squared is equal to 2e to the 0 plus c. So I decided not to go ahead and move anything yet, because all I really need is the e to the 0 will go away, right? So I think it's pretty manageable to solve for c here. 3 squared is 9. 9 times a half, you'll get 9 over 2. E to the 0 is 1, so just get 2 plus c. Subtract 2 from both sides. You get 9 over 2 minus 2 is equal to c. Okay, this would be like writing 4 over 2. 2 will be 4 over 2 is equal to c. And so this will be 5 over 2 is equal to c. So then I have 2 e to the x plus 5 over 2. Now I need the general solution, right? So I need the equation. I need y is equal to whatever the right side would be. So I need to isolate this y first. So by isolating this y, I would multiply everything by 2. 2's will cancel. I get y squared is equal to 4 e to the x, and then 5 over 2, the 2's will cancel, so I get 5. And so then finally, take the square root, right, to cancel out that, and I'll get y is equal to square root of 4 e to the x plus 5. Okay, that would be my answer. Alright, lastly, Form C, number 3. So it's finding a solution, but in particular in standard form. Okay, so find the equation of the graph that passes through the point 0, 2 and has the slope. We have the differential dy over dx is equal to x over 4y, and write your answer in standard form. Here's standard form. Okay. Again, pause it, study the other number 3 from Form A, and then try to do this one on your own, and then compare your answers. Okay, doesn't hurt you if you're wrong, right? It just shows you where you might still need to study. Okay, so here it is. That's in which it passes through. I think the easiest thing to do here would be to cross multiply. When I do that, I get 4y dy is equal to x dx. Okay, and so then I can take the integral. Here on the left side, if I add 1, I get 2. So divide by 2, I get 2y squared is equal to, and right here if I add 1, I get 2, divide by 2, I get 1/2 x squared plus c. Right, that's almost, again, I'm going to need standard form for this one. Okay, and so if I go ahead and subtract, I'm going to move the x squared term first as I work towards standard form, right? It's almost in standard form. I just need to get rid of this fraction, and I need to find c, and I'm pretty much poised to find c. Okay, I got my point there in which it passes through 0, 2. That's my x, that's my y. So I'm going to go ahead and plug in. If I plug in that x for 0, that term will just go away, right? Plus 2 times, and y is 2. So 2 squared, that'll be equal to c. Again, this term cancels out. 2 squared is 4. 4 times 2, I get 8. So c is equal to 8. And so then, okay, and I would say the last step would be then, let's get rid of that fraction, multiply everything by, I'm going to get rid of that first -2, so multiply everything by -2. So this first term here, the negatives will cancel, 2 over 2 will cancel, so I just get the x squared. -2 times +2, I get -4y squared. And then -2 times 8, I get -16. There you go. That will be the solution in standard form. Okay guys, make sure you take pictures of your notes, make sure you submit, make sure you watch the final section for Unit 7, which is 7.8. That'll be Friday's video, okay? And next week on Monday, we will begin our practice test. So practice tests start next week, and they will be factored or incorporated as part of your grade. Okay, and I'll have more information for you guys on Monday.